If you tuned in late, my name is Bill Simon, and I am on the board of Naperville Preservation. So there's lots of Naperville Preservation folks here this evening. Welcome to the meeting. And the rest of you know that I'm involved with Nest. So here's a saying you might have heard before: the greenest building is the one that already exists. Carl Elefante, who is a fellow of the American Institute of Architects and a past president, said this in 2007. The greenest building is the one that already exists. So you're probably thinking, what? How can this be? Oops. What about those leaky windows? And what about that lack of insulation, those old heating and cooling systems? Well, that's what we're here to talk about today, is how the greenest building can be the one that already exists. We're going to be talking about two concepts today. The first is embodied carbon. So some of you in Nest might be familiar with this term, but we're going to explain it. And then the second concept that we're going to be talking about is adaptive reuse. And the folks that are here from Naperville Preservation, they've heard this talked about before. So before we get into that, let me tell you a little bit about our organization, Naperville Preservation. We started over 5 years ago with the effort to save Old Nichols Library. So we started out as Save Old Nichols Library. That's what we were called. And that effort was successful. So today, Old Nichols Library houses a wildly successful Italian restaurant called Gia Mia. Some of you may have been there before, or some of you, like me, have tried to get in there but have not been able to get in. So during this period from 5 years ago to present, Save Old Nichols Library evolved to become Naperville Preservation. So here is our mission statement, and I won't go into it in detail, but it says that we're dedicated to being an independent voice for preservation. And we are the only grassroots organization in Naperville that does this. And our goal is to maintain the historic character and charm that we all love as citizens of Naperville. And we also believe that maintaining this historic character leads to economic vitality. So let me tell you a little bit about our organization. So this is the board of Naperville Preservation, and I wanted to highlight the background of a few of our members because they are board members because they are pretty strong. We see Joe McElroy. You may have heard of Joe before because he is a former Naperville city councilman. And before that, he was on the Plan Commission, and he has had a career in city planning. We have Tom Ryan. Tom Ryan is an architect. He is a former member of the Naperville Historic Preservation Commission, or HPC. Philip Buchanan is, his area is museum exhibitions and museum administration, and he's a former member of the Plainfield HPC, and he is also a member of the DuPage History Museum Board. And then we have Ron Keller. He's the one face that many of you may recognize. He's the director of our beloved Naperville Municipal Band, and he is the keeper of our history here in Naperville. He's quite the storyteller. And then the other people on the board down below, we have experience in accounting, corporate management, advocacy, and political action. And then we do have 50 members. Memberships, members, and then we have a pretty broad audience beyond that. So let's go to our first topic, because that's enough about us, and that is embodied carbon. So in very simple terms, embodied carbon is carbon that's released as emissions during the manufacturing and transportation of construction materials and in the construction process itself. So it's kind of the opposite of carbon sequestration that happens in trees. When trees grow, they pull carbon dioxide in, and that carbon dioxide becomes part of the tree. It's quite the opposite. When we build buildings, a lot of the materials that we use release carbon dioxide during the process of manufacturing them. So that is embodied carbon, as carbon that's attributed to the materials and released into the environment. So it's easy to see in this photograph here. You can see a multi-story building going up, and you can see two materials right here in this photograph. You can see these floor slabs that are made of concrete, and they have steel rebar in them. And you can also see these concrete columns with rebar also. And then, of course, down in the ground, there's going to be a concrete foundation that also has steel in it. There could also be structural steel that's part of this building. And these two materials, concrete and steel, are very carbon intensive, and that's what we're going to talk more about. But let's look at this nice, easy diagram, this cartoon that explains embodied carbon. So on the left side of this dotted line, you have embodied carbon. So that's the carbon that's from the manufacturing. So you can see this plant here is putting out CO2, is making maybe cement or some other building material. And then you have the concrete truck is transporting that material, and you have the actual construction process going on here that's releasing CO2. So that's as the building is being built. When the building is complete and goes into operation, people move into it, starts being used, then we have CO2 emissions. Those are operational carbon or operating carbon. So that's a CO2 that comes from the energy that's consumed in the building. A really great place that you can get an explanation of this embodied carbon is in Bill Gates' book, How to Avoid a Climate Disaster. And this is where I first read about this, and it really opened my eyes. He does a nice job explaining it. So one of the things he talks about is the cement. So again, cement is an ingredient of concrete. So where you have cement, which is like that gray powder, and you have aggregate and sand, and you mix that together with water. That's what makes concrete. So the process of making cement makes carbon dioxide. And Bill Gates explains here, if you make a ton of cement, you get a ton of carbon dioxide. So that's kind of a strange concept to think about something that's so heavy as cement and concrete releasing the same amount of carbon dioxide gas into the atmosphere. So you make 1 ton of cement, you get 1 ton of carbon dioxide. This picture here is a cement kiln. And if you look, you can see these people right here. Shows you how big this process is. They're on a little platform with some railing on the side of this kiln. So what does a ton of cement look like, that powder? Well, it's 32 5-gallon buckets is a ton of cement. So you get 32 5-gallon buckets, which I could probably fit in my 2004 Honda Odyssey, but I don't think you would like carrying a ton of cement in buckets. And that's going to make a ton of carbon dioxide. So what about steel? Steel is also very carbon intensive, because the process of making steel, we take carbon from this metallurgical coke and we infuse the iron with some carbon, but that process actually blows a lot of carbon dioxide past that never gets used. So making 1 ton of steel produces about 1.8 tons of carbon dioxide. 1.8 tons. That's a lot of carbon dioxide. So again, if we want to visualize, well, what does 1 ton of steel look like? It's 96 pieces of 20-foot long number 5 rebar. If you know rebar, you've seen it in construction here. That's what makes up a ton. Or another way to look at it is a 12-inch I-beam, 63 feet of that. So either of these materials, 1 ton, makes 1.8 tons of carbon dioxide. So how is that put together in a building? So this is a simple pie chart of some representative building that shows what the embodied carbon is of the materials that go into this example of a building. So you can see the biggest piece is the structure, this red part of the pie chart, 50%. So that's the concrete and the steel that's going into the building. Another 30% of the pie is in the exterior, the cladding. And then finally, the remaining 20% is in the interior. So that's for one building. So let's also consider this from a global standpoint. This pie chart might look kind of familiar because it's also in the Naperville 2036 report that NEST put out. But if we look at all the global carbon emissions in the whole world and what they come from, about 40% of that comes from buildings, from the operations of the buildings or from new construction. So this bigger pie, 27%, that's at operating carbon. That's from the use of the building. So this is like all the buildings in the whole world that are being heated and cooled, and electricity is being used in it for lighting. 27% of the carbon comes from that. So that's a lot of buildings, right? Because it's the whole world. But then you consider all the construction. 50% of that is from building new buildings, and then 7% is from building new infrastructure. So that's the global perspective. So let's go back to that individual building, and we'll look at it in a new way. And this is, well, how can we think of this in terms of the life of a building? So this is a life cycle graph of the carbon dioxide building emissions from a new building. So the way you read this is that bottom axis is the life of the building, starting at year 0 when the building is built, and then 1 year, 2 year, 3 years after people moved into it or it starts being used. And the vertical axis is the annual carbon dioxide equivalent of emissions. So every year it puts out carbon dioxide that's represented by that graph. And you can see here, this line on the left, that is the embodied carbon. So that's the upfront carbon that comes from building all that, or making all those building materials, and then building the new building. And then this annual line that comes after that, that's the operating carbon. So every year, the building's in operation, it puts out carbon dioxide for all of its functions that it's doing. And there's two bars here. There's the upper bar. This is kind of a nuanced graph. That's like a normal building, okay, a standard building. And then this hashed bar, this shorter, that would actually be a high performance energy efficient building. So there is a difference between a standard building and an energy efficient building, but the point is that these lines are much smaller than this initial upfront line. And this is calculated based on a medium-sized commercial office building, and it's looking at the life. And one thing you notice is that this annual number is going down every year, and the explanation for that is that it assumes that the energy consumption of the building is steady, but that the energy sources are being continuously decarbonized over time. So for that steady energy consumption, since the energy sources are decarbonizing, the CO2 is becoming less and less. So this also assumes that you have some maintenance or renovation every 15 years. But the point is, we can think of this in terms of annual carbon emissions up front and then annually after that. And we're going to use this concept later in something we're going to look at. So that's embodied carbon. So that's what we talk about on the nest side. So now we're going to switch gears and we're going to talk about this thing called adaptive reuse. Another word for adaptive reuse is really simple, is repurposing. So we all know about renovating historic buildings. So perhaps you have a building that's fallen into disrepair, or it just needs some updating. So we renovate it. But what happens if that building is no longer needed to perform its intensive use? Like, for example, let's say we have an old motel on a commercial strip. It's really no longer viable anymore because there's some shiny new motels that are built over by the interchange. So we can often adapt an existing building to a new use. So that's the idea of adaptive reuse. So adaptive reuse is really easiest to see than to explain. And this is like a really cool example that I found on the internet. This is an aircraft hangar that Howard Hughes built back in the day, probably like during World War II. And Google has taken this building and converted it into their Los Angeles headquarters. So let's take a couple other views of this building. So here's an interior shot, and you can see the existing building up above this wooden hangar building. And then, oops, I went the wrong way. And here's another one. Looks like a pretty cool place to work. And then maybe if you're in the tech industry, maybe you're actually living here too, from the stories you hear about people working many hours. But that's a really cool example. This is a description of adaptive reuse, and I'm not going to go through all of it, but basically we're converting to old to new use, and there's lots of reasons to consider adaptive reuse. It conserves resources, maintains historic value. There could be other environmental reasons, availability of land, all different kinds of reasons that architects can consider when they want to make a decision to adaptively reuse a building. So we actually have quite a few examples of adaptive reuse in Naperville and the surrounding area. This is one that we often forget about because it's been there such a long time. Fifth Avenue Station. Fifth Avenue Station was a furniture factory. It was the Kraler Manufacturing Company, and it was actually the largest employer in Naperville for many decades. And during World War II, they made aircraft propellers there for the war effort. And it kind of fell out of use, and it was repurposed in the 1980s to a mixed-use building. So if you've been in there, there is commercial space on the bottom floor and the ends, and then the upper floors are apartments. Here's another example. If you ever go to Quigley's, this building is across the street. It's North Central College's Abe House, which was originally called the Truitt House. Dr. Truitt was the first doctor in Naperville, and for a long time, he was actually the only doctor in Naperville. And the architect of this building was Harry Robinson. Robinson worked for Frank Lloyd Wright, so you can definitely see the influences of Frank Lloyd Wright's design principles on this. And this is a Naperville local landmark, and it's now North Central College's Center for Global Education. Here's another one that's in our next door neighbor, Aurora. It's the Two Brothers Roundhouse. So many of you have probably been there. This is an old CB&Q railroad roundhouse that was built in 1856, and it was converted into a stunning restaurant in 1995. And the primary investor was Walter Payton. So it used to be Walter Payton's roundhouse. More recently, it's been purchased by Two Brothers Brewing. And interestingly, the Two Brothers actually have their origins in selling home brew supplies in Naperville, but that's another story. And then here's one of our favorites with Old Nichols, with Naperville Preservation, is Old Nichols Library. This is the original Nichols Library building. James L. Nichols, who donated the money for this, was a professor at North Central College and a very popular business writer, and he funded this library before Andrew Carnegie began funding libraries all across the U.S. And the architect is a notable architect. It's a beautiful building, and it is a Naperville local landmark, thanks to the efforts of our group and also many members of our community who wanted to make sure that that building was protected. And this is not in Naperville, but our next example is the Godzilla of local adaptive reuse, and that's the old Chicago post office. I'm sure everybody's driven under this. Driving to downtown Chicago was originally built in 1921, a small section of it, but greatly expanded in the 30s because of all the mail order business with Montgomery Wards and Sears. And it was vacant for about 50 years and finally reopened. And it's a really hot office space. You can see some of the list of the larger tenants that are in the building. And it's gotten a lot of recognition for all the energy efficiency and environmental aspects of the building. So that's adaptive reuse. Let's put the two together in a case study. So we take embodied carbon, adaptive reuse, and the question is, how can we quantify the carbon-related benefits of adaptive reuse? So this is a study that was performed by two architects, and it is the Boston University Hillel Center. And this presentation was given just last year as part of the National Trust for Historic Preservation webinar. So this is a view of the Hillel Center being built in the 1950s. So you can see this wedge-shaped building that's adding onto this existing building that was built in the 1800s. So the project in 2016 was to renovate that 1950s building. So you can see here, this wedge-shaped building here is that Hillel Center. And it was converted into a welcome center, and that's also where the admissions offices are. So this project was used as a basis for the study. And they used a new tool that's called the Carbon Avoided Retrofit Estimator. So you always got to have a cool acronym, so I guess they thought this was cool. And it's a pretty sophisticated model that takes a lot of variables about the existing building, the new building, you can put in different renovation scenarios, takes into account the climate. And then also, importantly, one of the things you put in is, what is your desired target horizon? So let's say you want to look at carbon dioxide, carbon emissions from now until 2036. You put that in there, and that's what it's going to use to do your scenarios. So for this project, the Hillel Center conversion, and here's what they got. So this is a graph that shows the total cumulative carbon emissions over a 15-year period, from the point of you starting construction till for 15 years. So the way you read it is, the bottom is 3 scenarios, and then the vertical axis is your carbon emissions. So you got 3 scenarios. You have do nothing, which is like, just continue using the building as it is. And then the middle scenario is a retrofit or renovation scenario. So that's where you're going to convert the building into a new use, but you're not going to tear it down. And then the third is a completely new building. You're going to tear the building down and you're going to build new. And what you can see, of course, is if you do nothing, you're not building anything new. So you have no red bar. The red bar is embodied carbon. The yellow is operating carbon. So red is up front. So it's all operating carbon, and you can see you're putting out quite a bit of carbon dioxide due to the inefficiency of the building. If you look at the renovation scenario, you have embodied emissions, embodied carbon, because you're putting new materials into the building, but you're getting a really good reduction in the operating carbon. And then the third scenario, the new building, as you can see, you get a lot more embodied carbon from all that new construction, and you are getting a reduction in the operating carbon. But in this case, the new building is actually putting out much more carbon emissions over that 15-year lifespan than the renovation case. So let's look at it a little different way. This is a graph, kind of goes back to that one where we looked at carbon emissions over time, but this is the same idea, but this is cumulative. So every year we keep putting out more carbon emissions and the graph goes up. Time is on the bottom axis. The vertical axis is carbon emissions. We have 3 lines. The do nothing case, the renovation case, and the new construction case. So the do nothing is orange. So you have 0 initial embodied carbon. It's all operating. And it has the steepest slope because it's putting out, a lot more carbon dioxide due to the energy consumption of that building. So the second line is the yellow. This is the retrofit or the adaptive reuse case. You do start out higher because you have that initial embodied carbon, but since the building is more efficient, it's putting out carbon at a lower rate. It's got a lower slope. So after about 4 years, 4.5 years, it's gonna break that initial expenditure of carbon emissions that goes out. It's gonna break even, and it's gonna start having a lower emissions than the do nothing case. Well, what about a new building? A new building is all from the ground up new, so you have much higher embodied carbon in that initial construction, but you're much more efficient, so it's flatter. And as you can see, the embodied carbon in this 15-year time horizon that we're looking at is the total carbon of a new building is higher than the retrofit case. It's better than not doing doing nothing, but in this particular example, the lowest case over a 15-year period is the retrofit case. So when does that does the new building break even with the retrofit case. In this case, for this building in this model, it took 47 years for the new building to have less carbon emissions than the renovation. And this is consistent with some of the other ranges that I've seen in some of the readings online. So why is this important to Naperville? Well, first of all, we know from what Ness says that buildings represent the largest portion of our community's carbon emissions, and that's about 75%. And you can find this in the Nest report, the Naperville 2036 report. And in fact, if you look in there, interestingly, you'll find that Nest actually recommended adaptive reuse as a strategy for reducing our community's carbon emissions. But it turns out that that strategy is not in the city's current work plan. So why else is it important to Naperville? Well, Naperville is pretty built out. That means, we're not in the days where we were just, building new subdivisions and growing out. We do have some infill development, and we are incorporating some additional land on the south end of town. But a lot of the construction that's going on is really tear down construction. So we have existing buildings that are torn down. We see this downtown in our commercial corridors. At the city council meeting tomorrow night, there is a case that's going to be discussed about a strip mall on Route 59. And we're seeing this in residential areas around the downtown and then a lot of the older subdivisions farther out. So let me show you a little example of this. This is the East Highlands subdivision. So if you look here, you'll see the river here. If you don't know where East Highlands is, this is the DuPage River. And so this is east of the river and south of Chicago Avenue. And then down here, this green in the bottom is Veterans Park, if you know where that is. So in the East Highlands subdivision, over half of the houses in the subdivision have already been torn down and replaced with new buildings. And this is ongoing even as we speak, even with the slowdown in the overall housing market. This teardown activity is ongoing. This is a study that Naperville Preservation commissioned. Some consultants called Preservation Futures did this. And we funded them with a grant from the Naperville SECA fund. So the last reason that this is important for Naperville is because of what we've been talking about tonight. Renovations and adaptive reuse are a really good means to reduce our carbon footprint going forward. And now there are new tools that are coming out that can help policymakers, owners, and interested private parties to get data so that they can make decisions about redevelopment. So to wrap this up, let's go back to Carl Elefante, who had that quote about the greenest building. And I'm not going to read all this to you, but the first line, he says, existing buildings are a resource for tackling climate change. And if you go down to the bold print that I've made bold, retrofitting existing buildings to meet high performance standards is the most effective strategy for reducing near and mid-term carbon emissions and the most important step in limiting carbon disruption. So that's my presentation. Thank you for listening. Preparing for this really gave me the opportunity to pull together these two areas, historic preservation and sustainability. And I can tell you, I learned a lot in researching this presentation, and I hope you did too. If you would like to learn more about our organization, you can visit our webpage and Facebook. Just Google Naperville Preservation. We pop up first. And then also check out our YouTube channel. We do have some tours of various homes and buildings on there. The two that we did late last year with the help of NCTV 17 is a tour of a mid-century home in the East Highlands subdivision that is very cool. And then also a visit with our favorite brat shop, Kreger's. So if you're a Kreger's fan, you'll want to check that out. And when you go to our website, make sure you sign up for our email list. And then likewise, for those of you here tonight that are supporters of Naperville preservation, please check out the Nest website, and you'll see a place to subscribe for Nest's email. So that's what I had to say tonight. Thank you very much.